Alright, in this video we're going to start applying the chain rule in conjunction with some of our other rules, namely the product rule and the quotient rule, and how we're going to apply those in combination with the chain rule. It sometimes takes a little practice to figure out which rule gets applied first and things like that. To me, I always think about it as this concept. What would happen if I were trying to calculate the value of y in a function for a particular value of x? Like, say I put x equals 1 into this function. I would substitute 1 in for x cubed. I would substitute 1 in for 2x minus 3. I would take that 2x minus 3 and raise it to the fourth power. And then the last thing that I would do is I would multiply those two values together. When we're applying the chain rule, we're going to, and in context with the product rule and quotient rule, we're going to go in exactly the opposite of the order that we would do calculations if we were evaluating. So the last thing we did when we were calculating was we multiplied the x to the third and the 2x minus 3 to the fourth together. And so the first rule that I'm going to apply to take this derivative is going to be the product rule. Alright, so let's go ahead and take this derivative. We've got dy dx equals x to the third times the derivative of the quantity 2x minus 3 to the fourth plus 2x minus 3 to the fourth times the derivative of x cubed. And now we're going to go ahead and take those derivatives. So we've got dy dx equals x to the third times, and now we want to apply the chain rule to find this derivative, the derivative of the 2x minus 3 to the fourth. So that's going to be 4 times the quantity 2x minus 3 to the third times the derivative of the inside. The derivative of the inside is 2. And then we're going to take the derivative of x cubed, which is 3x squared. Now I'm going to clean this up a little bit. So we've got dy dx equals 8x to the third times the quantity 2x minus 3 to the third plus 3x squared times the quantity 2x minus 3 to the fourth. Now I want to simplify this by taking out any common factors that I've got. So I can factor out an x squared, and I can factor out a quantity 2x minus 3 to the third out of both of these terms, which leaves behind in the first term 8x, and in the second term 3 times the quantity 2x minus 3. And now I'm going to simplify what's inside the parentheses, or inside the brackets, pardon me. And that's going to be, we've got a 6x minus 9, so that's going to combine to be 14x minus 9. And there is our derivative for y in this example. So we applied the product rule and the chain rule in this problem. Alright, let's go ahead and look at example 6 now. Alright, in example 6, we have y equals the quantity 1 plus sine of x over 1 minus sine of x raised to the third power. So we're going to apply the chain rule first, because the composition is the last thing that we would do if we were evaluating this. So dy dx is going to be the derivative of the outside, leaving the inside the same, times the derivative of the inside. And when we go to find the derivative of the inside of this, we're going to apply the quotient rule. And so I've got low times the derivative of high, the derivative of 1 plus sine of x is cosine of x, minus high times the derivative of low, which is negative cosine of x, all over low squared. Okay, and now I need to clean this up a little bit. So I've got 3, and I've got the quantity 1 plus sine of x, quantity squared, over 1 minus sine of x, quantity squared, in that first piece. And I've got cosine of x minus sine of x cosine of x plus cosine of x plus sine of x cosine of x, making sure to distribute my negative sign through that whole thing, all over quantity 1 minus sine of x quantity squared. And now the sine of x cosine of x's in the numerator here cancel out, and we end up with 2 cosine of x there. And so squeezing this all together, we're going to have 6 cosine of x times the quantity 1 plus sine of x quantity squared, all over the quantity 1 minus sine of x quantity to the 4th power. And there's our derivative for example 6. Alright, that's the end of this video, and we're going to continue on with examples 7, 8, and 9 in the next one. See you then. Have a great rest of your day.